Hello, everyone. Let's take a look at LeetCode 153, find minimum in rotated sorted array. It's appeared in a lot of interviews. For example, recently there are some interviews like Facebook interviews, Amazon interviews. They all tested this problem. Okay, let's take a look at this problem. There are some similar questions. For example, LeetCode 33 and LeetCode 81, search in rotated sorted array. They're very similar. So if you haven't practiced those problems, you can take some time to practice them first, since they're very similar and they have the same principle. Okay, let's take a look at this problem. Suppose an array of less n sorted in ascending order is rotated between 1 and n times. For example, the array is 0 to 7. It might become like 4, 5, 6, 7, 0, 1, 2, or 0, 1, 2, 4, 5, 6, 7. So all the elements in this array are unique elements. So we need to return the minimum element of this array. We know there is one naive solution. It's O(n) times complexity. We just search every element. So we just do linear search. But it's too slow, so we should improve it. So we can use binary search given the sorted property. So we can do binary search, but how do we do binary search? Let's take a look at these two examples. In the first example, we know there's some ascending order, but it's not that long. Then we rotate it, and there's another ascending order. It's long. In the second example, there's a long ascending order. Then we rotate it here, and there's not a very long ascending order. So we can distinguish those two cases very easily, just checking the mid element. If the mid element, we can say, if it's smaller than left, we know it's this case, or if it's smaller than right element, it's also this case. Like for this one, the mid element is greater than left or greater than right. So by checking the mid element and the left element or right element, it's very easy to distinguish the cases. So in this case, minimum element is in the left part. We need to include in mid, since mid may be also like minimum element. So we need to set right to mid, so we can just search the left part. For this example, we know we need to search the right part, and mid is not it's impossible to be the minimum element. So we just set left to mid plus 1, so that we can search the right part. Okay, so far so good. So the code looks like this. We have two pointers left to right, which is I and j. I is 0, j is the last index. While I is smaller than j, we get mid, and we check if mid is smaller than left, it's the first case, so we set j to mid. Otherwise, it's second case, we set I to mid plus 1. Finally, we just return nums I. Okay, does it work? Okay, for example, array is 1, 2. Let's check if it's working or not. In this case, I is 0, j is 1. So mid is also 0. In this case, mid is 0, I is 0. So it's same. So we just go to the else branch. I becomes 1. So finally, we just return nums 1, which is 2 in this case. But 1 should be our answer, right? So we will skip 1 in this case. Since nums mid is same as I, so it's comparing with itself. We skip it. What shall we do? We shall compare with right. Okay. Which if we compare with right, we know mid is 0, j is 1. So nums 0 is smaller than nums 1. So we set j to mid. So j becomes 0. I is also 0. So we will break this while loop. Then we just return nums 0. It works. Okay, so we need to compare with nums j in this case. Okay, that's it. See you next time.